What's up, YouTube? This is the fourth video on Kyle's Global Weather. This video is going to be divided into a few different segments. First, it's going to be an educational segment about the role that temperature plays in the ocean, just some external information about it, what its effects are. We're then going to be talking about Eastern Asian snowstorms that are going on right now and in the next couple of days. I know it's pretty repetitive to our last video, but it's still really interesting that we're having these in this time of year. And then we're just going to end it off with our classic New York City forecast and just a few extra thoughts from me about the future of this channel. Let's get this going. Just gonna spend a few minutes on warm waters. There's a few main reasons why temperature in the ocean can change. Number one is the sun, and the sun produces rays all the time, 24/7. And when they hit the ocean waters, the ocean is going to absorb that energy, and that's going to turn into heat. And depending on how far north you are, it's going to be more or less. It's going to be, if you go north, it's going to be less sun rays that are hitting you. So that's why the waters are going to be cooler. And it's because the Earth is rotated away and the sun has to pass through more layers of the atmosphere in order to reach the ocean. Then we got wind. There's many different ways that winds can occur, many different patterns and cells and everything that we attribute wind to, we classify it as. It could be the jet stream, it could be offshore winds, it could be cells, so many different things. But that's the second reason. And then the third reason is something that's underwater. It's called the thermohaline circulation. And it's a process in which colder and denser water sinks to the bottom. And then when it does that, it circulates around the ocean floor. And it contributes substantially to global weather patterns. You've probably never heard this word before, but it's very substantial. And these are just the three main reasons why temperature in the ocean would change. So now, why do we care? What is the effect of it going up? Here's one of the biggest things. There's a lot of environmental impacts, but we can just start with this. Evaporation is more likely. So when there's higher temperatures, there's going to be greater kinetic energies in the water molecules. When there's greater energy, the particles are going to be moving around faster. And that's going to cause a lot of them to break away from the IMFs or intermolecular forces that bind them together in their liquid state, and they're going to become water vapor. Now you might ask, Kyle, how is this possible when it's not 100 degrees outside, 100 degrees Celsius outside, and this is just happening all the time? Well, it's because of the vapor pressure. And also, temperature cannot be looked at as just a simple thing. Temperature is an average of kinetic energy. Some molecules are simply just going to have higher kinetic energies, and that's what's going to cause them to become water vapor. Another common misconception is, I know that moist air is going to rise, but how does that make sense? Water is more dense than air. That's actually not true. Water vapor is less dense. It's about 33% less dense than air. So we got the warm, moist air rising. Can't speak. So then what? Well, it's going to interact with cooler layers of the atmosphere. Right? And then when that happens, the water is going to want to condense. But where is it going to go? It's going to go into certain particles like salt, even microorganisms like dust, all these different things. It's going to rest there, and that's how clouds are going to form. Now, we could talk a lot more about these in future videos, but certain clouds, they're more conducive to producing storms and rain. And when there's moist air in a specific, area of the atmosphere, that allows for more of that moisture to become rain. So it's a cascading cycle, if you will. So yeah, we're just going to talk about this more in detail in future videos. All right, let me get out of this. Okay, so this is just a sea surface temperature. We're going to discuss Southeast Asia, and I just wanted to have this as an example. This is the sea surface temperature right now, and this is an anomaly graph, meaning the departures from average. These warmer colors indicate that it's going to be a lot more above average, and the cooler colors like green and blue indicates that it's below average water temperatures. This is for right now. This is 5 days in the future. As we're going to begin to discuss, this storm is going to be happening right now. So you may ask, how is it that these storms are forming at only certain times when there's warmer water temperatures? And then when it's other times when it's even warmer, you can see, it's even brighter colors here. Why is there not a continuous storm? And that just goes to show that, well, it's a really complicated answer, and that just goes to show that there's just so many factors, even like dozens of factors that go into storms, just meteorological events in general. You can't pinpoint one specific thing to causing something else. It's just a multifaceted issue. And then once we, describe all these things, you just want to keep in mind that, there's a lot of things to consider. This is a precipitation model of Southeast Asia. It's not Southeast, Eastern Asia. This is right now, about 6 o'clock UTC. See this as we progress. This storm is going to deepen. You can see it going from 1005 to 996 within a 12-hour time frame. And as that happens, the precipitation is going eastward. The storm's going eastward, heads out of South Korea, and then it brings substantial storminess to Japan, moderate to heavy rainfall, and even some snow to some of the same areas that we saw a few weeks ago. It's getting pretty unusual, Japan. You guys got to stop. As for snowfall, just a few inches, centimeters in South Korea. As we get into Japan, it's going to be more like a foot, 20 to 30 centimeters, just for the mountainous areas. And this is something I wanted to introduce. This is called a quantitative precipitation forecast map, and it just describes the total moisture precipitation. Now, it doesn't matter what kind of precip there is. It could be rain, snow, sleet, hail, freezing rain, acid rain, and like even more, right? A combination of all of those. Doesn't matter. We're only considering the rain part of that. And just, if we were to melt all these things down, how much water is there? As we go into the future, if this wants to load, yeah, you can see it. The heaviest amounts popping in is Japan. If you want a numerical scale down here it is, about 30 to 40 millimeters of snow. Of rain for like a lot of these areas, right? If it were not to fall snow. I thought it'd be pretty interesting looking across the world. These are some news outlets. This is South Korea. And, if you can read Korean, that's awesome. I put some of these into Google Translate, but they're all agreeing that there's a snowstorm on the way. And the same thing for Japan. I can't read Japanese either. It's so cool, right? We're just going to connect something to this past video to segue ourselves into the third segment, the forecast for our tri-state area. This is a geopotential height map. It's an anomaly map. You can see on the right-hand side, we've got these warmer colors, indicates higher heights and above average temperatures, higher pressure usually. And then on the left, we have cooler colors, lower heights, lower pressure. Here's an interesting feature I have not talked about yet. See these isobars right here? Look how they're a little bit squiggly. That's important. Normally, if it's a straight line, it just indicates straight jet stream in the mid-levels of the atmosphere. But with this, it's indicating that it's not really a constant flow of air. There's some other stuff going on. And when that air, sometimes it might be acting perpendicular or at an angle to the jet stream, that is what causes activity, and that is what causes intense storms. And this region of the United States, the Ohio Valley in the southeast, experiences this all the time. As we get into Thursday, we got a low pressure system forming off the East Coast. And these colors just get deeper and deeper for a few days, Thursday into Saturday. It's actually right about the point where we expect snowstorms to be. It's March, but there might be some cooler temperatures as we get into the precipitation forecast. Spot on. I did not even have to look at this, so you can just see how everything is interconnected in some way. Storminess riding along just a thin streak of thunderstorms. You can see those, deeper colors riding across where the Mississippi River is all the way into the southeast. Nothing too special, pretty expected for this time of year, but it's going to work its way into the southeast. It's going to weaken a little bit and then re-strengthen as the storm forms. Goes from 1002 to even 992. It's going to be affecting the tri-state area for like a few days with moderate rain. I don't think this is going to start as early as this predicts. I just don't see how the storm could be 800 miles wide. That's just my experience. It might turn out to be like that. We'll see. But what's really interesting about this is the snow that comes along with this. The latest European model is predicting snow for the tri-state area and regions north and the northeast about 4 days out, which is a pretty nice degree of accuracy, just being 4 days out. This is probably going to happen somewhere around this region. It's going to snow. Just craziness, right? The more south it gets, the more weird it's going to be. This is the forecast for New York City. Just put it in New York City because that's central area of the tri-state area. Going to be most relevant to most people. And pretty standard stuff for this time of year. Average temperature is somewhere around 11, 12 degrees Celsius. It's going to be raining on Thursday. The Weather Channel concurs that that's going to happen. And I think this day on Saturday, it's going to be a little bit warmer than what the Weather Channel is forecasting. It says only 14 degrees. I'm going to hedge my bets on that. Okay, it's going to be like 16. It's going to be very sunny after a storm system. It's probably going to warm up a little bit more than they say. That's pretty much it. Hope you guys enjoyed. I like to just say a few thoughts on weather content on YouTube as a whole. I'd say there's two main types of videos that compose maybe 90 to 95% of the content that's out there on YouTube. And those are either simple videos and complex videos. In the former, it's meant to target a wide audience who just wants a little synopsis of everything. And it's going to have perfect illustrations. It's going to be like just like the main broad things that you might want to know. But then you have these really complex videos, and they have really bad editing. They're not very engaging. They could be very interesting, but they require like a whole like years worth of knowledge even to understand all like a good amount of them. So what I want this channel to be is somewhere in the middle. Takes the best aspects from both of those, right? Great engagement, great illustrations, but also allows people to not only have information that's useful, but information that allows them to explore weather on a deeper level. That's my vision. That's going to come in the forms of education, current events, maybe even something else. So yeah, I hope you guys enjoyed that. See you guys in the next one. Peace.